Hello and welcome back to the Power Shed. Today we're going to talk about an on-time limiter. And what I'm dealing with here is I have an old Harbor Freight MSW inverter, and this one over here runs my fridge, and I've modified that already. But this one is to show you this little modification I made, and it's just kind of interesting. I've been having trouble with my refrigerator, and it's because I have a nearly dead battery, and I paralleled it up with two little batteries I got from the town recycling. It's battery exchange. But anyway, before I lose this image, this is the startup on my refrigerator. This time period here is 2.6 seconds. 2.6 seconds of hell. And what it does is it draws a lot of current, and these batteries weren't able to supply it, and I was getting some shut-offs and everything like that. And I've been thinking about this idea for a long time. Everyone complains about MSW inverters, and you can't use them with motors because they hum and they overheat and cry. And there's technical reasons. And basically you have an on period, an off period, and then it cycles back and forth. These on periods are really too long for a motor, because once you've reached the peak and the magnetics have saturated, the motor just looks like a resistor, and you actually have this force which is pulling the motor back slightly. And so what I've decided to do was cut the on times down significantly, about 20%. Normal time is about 4.8 milliseconds on, and I've changed that down to 4 milliseconds. Now, one of the interesting things is, instead of regulating the high voltage, it's this area underneath the curve which gives you how many watts that you can get out of the thing. It's basically replacing the sine wave with this little square thing, so you get the equivalent heating with a light bulb or whatever. And one of the bad things about MSW inverters is when the voltage of the inverter drops down slightly, they widen the on time, which is exactly opposite of what you want to have when you're trying to start a motor. And so I've done this little limiter. Now this output H bridge uses an SG3524, and there's different ways that you can do to limit the on time. And what I've done is the comparator pin coming out of the chip, I just attach that to a diode, and when this gets over a certain voltage, this voltage divider sort of clamps that. It's just a output of an op amp. It doesn't take much to load it down. But the values I see here, 12K, 5K pot, and 1K on the bottom, you get about 0.8 volts. And remember, your diode adds another 0.7 volts to that, so it's about 1.5 volts. And I've dropped it down to 4 milliseconds from 4.8, and my startup current went from close to 120 amps to about half that, and the thing runs much less current. It's it runs fine, and everyone complains, but if you buy a refrigerator with an inverter drive, guess what you're getting? You're getting square wave pulses out to the motor. But this works quite well, and let's just set this back up here. There we go. This is on this inverter right here, and I have this little pot, and as you can see, we can adjust the on time by setting the voltage. This is really interesting when you get towards the yeah, see, there's a really short on time, and then you can get it a little bit bigger. Anyways, you can adjust it up, but what you saw some funny stuff there is the high side FET is driven by what they call a bootstrap. So basically from the 12 volts, there's a high voltage diode like a 4007 that can take a lot of voltage. And that feeds this capacitor. So every time the output goes low, it charges up the capacitor. If you make the time really short, that capacitor doesn't have enough time to charge up, and there's not enough drive signal. So you have to be really careful. You do these things with out of load on them. Otherwise you can burn up some FETs. And on the output, remember it's an H bridge, so it's floating against above their natural ground. And if you ground anything, I just had to, there was a FET right here. You know, everyone thinks they're smart and they won't make mistakes, but I had the scope hooked up and I hooked up the ground and I did something different. And basically, the output I shorted through the ground leads of the scope and blew out one FET. So it's easy to make mistakes. Always use an isolation transformer on 120 volts. And as you can see, you know, the transformer works really nice. That's a clean signal coming out of there. But that's what I wanted to discuss and have some fun with an on-time limiter. So if you have access to some of these old MSW inverters, which actually have you know, discrete chips instead of a microprocessor, they'll have a SG 3524 or TL494 or 3525. You can play around, and like I say, this one can't get any longer on time than 4 milliseconds, and it cured all the problems. Just kind of interesting. I've been wanting to do that for years. Thanks for watching.